All right, we are live. Um, I have not. Let me just make sure we're up on YouTube, so we can. Great. All right, we're up on YouTube. This is my. I apologize, everybody. Normally, I am not the. I'm not the person setting this up, and I am actually at a different location, which is a nice way to loop in James here, because we met probably a couple months ago. I think now. I
Yeah.
was
Oh,
at
yeah.
my parents' house in Massachusetts, where I am right now, and I saw that he liked a Prospero post on Twitter, and I noticed his location, and it's really like a marvel, I would say, of the work from home world. Where I looked and I saw this AI fellow at NASA a few towns away from my parents' like small town where they now live in Western Massachusetts, and as most people that live and breathe and work with AI do, we we had a great first conversation about AI and many other things because we both like talking about AI, and so after a few of our conversations, I decided to suggest this. Very happy that James made the time today. Maybe you want to introduce yourself before we kind of jump into the questions.
Yeah, sure. Hello, everyone. As uh, as George mentioned, James Villarrubia, um, applied AI expert. So if you're going to ask like PhD level questions, not my game. If you want to talk about how to use AI in like your business and grow business with it, that's more my jam. Before currently at NASA. Before this, I did a lot of CTO roles in a variety of sort of social impact startups with AI, with former Gov. But I do want to make clear I am here. Legal reasons. I have to say, like, I am here on my own, representing my own opinions. These are not the opinions of the federal government or NASA or the GSA. I just work for them. But yeah, no, super excited to be here. I'm really glad to have sort of like randomly clued in on Prospero and connected with George. So super excited to be here.
Yeah, James, like I'm sure many of you here is also a Prospero user. He's been pretty excited from some of the early net option sentiment results, and it's always nice. We one of the things I would say that's been pretty surprising about the signals is they were really built to have kind of an easier view of things. People, I thought they were going to help more like novices to intermediates, and then we have some pretty advanced finance people and AI people using the signal. So it's really nice that it can span all of those different kind of experience levels and technical expertise levels. But we're gonna just dive into the questions, and we're gonna
Yeah.
we're gonna start with probably my favorite one. And you've all heard my opinions on this, but what the best AI companies are in terms of their technology, in your opinion?
um, well, I think if we're gonna write sort of oh, did my camera disappear? Nope. Okay. Um,
No, I'm
it
trying to. I'm even trying to figure out how to like. I think we might just both have to be here.
all right there.
Oh,
Yep.
that's a little better. I'm like, I
Oh.
don't know how to do the speaker. Like, I was trying to do
Mm,
um, the who's talking thing. So you have a very inexperienced proctor here. Like, I did it on one, but shouldn't it? Wait, I'm gonna stop talking.
all right. Let me. Nope. Well, I think there's only two of us, so that might be the that might be the
There we
challenge.
go. We're gonna
Um,
just stick with this.
yeah, yeah, this is fine. Yeah, so I mean, I think time will tell, but I suspect 10 years from now we're going to look back and say that Microsoft sort of like early investment in OpenAI and sort of the sweetheart deal terms they got on sort of exclusive usage for X many years to recoup their investment. All under the guise of a nonprofit relationship. I mean, that to me was brilliant. Maybe a big bet, but brilliant. And talk about bringing Bing back into the conversation and chat like, oh, I'm going to use chat GBT is now sort of like a verb, as much as Google, I'm going to Google something is. So they have a real opportunity here I think, to shape a market, which they've been lagging in sort of the search space, and not known for their AI expertise for a while. So really interested to see how that shapes out. I can't say that from the sort of cloud side that I know a lot of people who love Azure. it's not like the go-to for a lot of like young companies and devs. So I think they still struggle there. But hey, if they've got, like, hey, come in and we'll tap into ChatGPT, it's great. But I do think it's sort of like on Google and Amazon to sort of pick up the slack. That being said, I think Google has some interesting. They're coming at from like an interesting angle. So they released Bard. I was like, okay, it was it's competitive. It's out there. They want to get something off the shelf. It had some marketing PR issues in the beginning. But the thing that really struck me was their Palm 2 model and their Gecko sized Palm 2 model. So if you don't know Palm 2 is one of their large language model training sets. Gecko is like I think their smallest size of that model. And if you were trying to figure out which company had the greatest advantage in getting device deployed or on device models rolling in the market, I think that Gecko model and Google is like where it's headed. So if you can imagine sort of like a AI assistants like your Amazon Alexa or whatever trying to tap into ChatGPT, well, it's got to do that whole round trip back from the device to the web, interpret your sound, process it, do the search, send it back to you, and then say it out loud. That could be 30 seconds, which is not a great user experience. If you could do almost all of that initial transcription and interpretation on device, the user experience gets way cooler and a lot more sort of like the sci-fi movies and we're talking to our house sort of stuff. But to do that, you need something on device, and you can see sort of interesting pieces like Google having a very small model, and even and here's a real kicker: Google and Amazon have joined forces. Not a thing you hear really, really often. Have joined forces to come up with a universal set of like AI assistant commands, like a universal API, so that both they sort of compete on the software side, not the hardware side, and they're working with JBL. And so to me, that's like, oh, we're pulling out like the Google Home and the Echo and all that, to sort of stepping back from that market, which we already knew, but investing on that like heavily on the software side. And Microsoft is not included in that partnership. So to me, that's the inside scoop. And then on the Amazon side, I would say the thing that is most intriguing is they've got Bedrock. I think it just went yesterday. I think it went to general release. Cool. It's an AI model. Great. Yet another LLM. But the thing that really got me about Amazon, the signal that I saw was that they have it's like a SageMaker plus something, some variation of the SageMaker platform where you can just pick a model off of Hugging Face, anything on Hugging Face, and they'll just spin it up on Amazon for you.
For those that don't know, Hugging Face is a popular sentiment analysis tool. Some of the people that watch this are kind of like on the lower level. We're not all AI
okay,
experts.
yeah.
And a few other things that I would add to what he said. I mean, it seems like you're mostly talking about like chatbots and interactions with them, right? Because I mean, the thing for me is I always talk about DeepMind, MuZero, and kind of that being like a pure technology play that's kind of like the best brain out there that could build and enhance a lot of products. Like my thing with Google, and actually people ask me this, and it's like one of the questions that I just like one of the few ones I have answers for most, where I say like I don't know. People ask me like why Google doesn't just have a hedge fund, with like MuZero, which is essentially, for people that don't know, it's a program that learns on its own using GANs, which are adversarial networks that basically compete against each other. So it's basically simulating all of these games on its own, like Alpha or Go is a game that it like learned very fast on its own in an hour, and it could beat any of the other things that played Go and like all of it. And the idea is it no longer has to compete and play the games against others to learn, which is what computers had to do to improve for a long time. So yeah, the question is like, why not take something? And they don't mention MuZero specifically, but I always do. I'm like, yeah, like they could throw like a game learning brain like MuZero at their data set, which is, all of this real-time search information from people's emails, like, etc. They could. Like, my answer is like, I don't know why they don't invest. They could make a boatload of money really quick. But honestly, I think they would just like break the economy and piss off Wall Street, which is probably the
I,
most powerful special interest in the US.
I mean, I think like when you say like MuZero, like using MuZero to create a hedge fund,
Yeah.
or
Or
like
just like
okay,
teaching it how to trade, like simpler. Like, it doesn't care about
okay,
the structure. Just like, hey, go make money instead of go beat this player at Go. Like here, these because it doesn't have to learn rules anymore. Like the earlier
yeah,
systems obviously had to learn rules, and now they just say, here's the game. Like, here's the
yeah,
data set. Like, here's trades. You trade better. Like, that's your goal. Make more money than these other trades.
yeah,
And there's actually no reason why they could, like,
yeah.
I don't know if you have one, but
I mean, I bet you someone is out there doing that, and that it may not be something that they talk about publicly because again, sort of like if you publicize it, then your advantage goes away. My guess is there is probably a shop or someone out of the DeepMind ecosystem of people who's like, yeah, like I'm gonna build this and trade on it. And they're quietly amassing their billions, and we won't find out till later, till they retire and or name a library or school after themselves.
oh
So
yeah.
yeah, I mean,
But I
assume
think
it is
there's
happening.
the code and the data. Like I think MuZero without Google's data set, you know, is better than like, Bridgewater, Renaissance Technologies. Maybe nobody really knows what their technology does, but
Yeah.
theoretically better. It is like, probably the best AI model that we know of. The Chinese government probably has something better. Who are we kidding? But like that we know of, it's probably one of the best. But like, yeah, I think it's like personally, I think that Google is just too worried about blowback of, because I don't know
Yeah.
the legalities, you might know better, but I think it's illegal to share that data or like read people's emails or what have you. But I don't think in feeding it
Mm,
like a person, but I think feeding it in even just like a compressed like
yes.
format to a machine learning model that's going to trade, I don't think there's any laws against that, right?
So yes. So that my suspicion, not a lawyer, but my suspicion. I mean, the terms around sort of Google Business Suite and saying, "Hey, I'm on the G Suite platform," or my company uses emails. Like the idea of Google using that information to trade would be a like massive SEC violation. Like one per email read sort of count or per trade. I mean, yeah, I think that they would. Uh, Steer pretty clear of that. Um, but there's enough data out there. I mean, I was having a conversation with someone about sort of like all the various data ecosystems that people participate in and just don't realize it, and how cheap that is to get. I mean, I think John Oliver had a whole skit around this of like he bought a whole bunch of data and was like, "I'm gonna find the congressman," and was able
Yeah.
to like, oh, like they happen to hang around the this area. They're between these ages. They are also fly out of this airport to this space. Like, yeah, I can name this congressman and this congressman, and oh look, here's their web history. Like he was basically saying that the data privacy is sort of a joke in this country. So I suspect you can if you have access to that and the compute power to actually make sense of it from a trading perspective. Um, yeah, you could probably do a lot. And I guess to me, the reason, like, again, you get sort of like fast. There's always a worry about sort of using back data about sort of like overfitting to sort of the market. And I think in sort of using any sort of live trading thing, you don't know until it's going to look great until it doesn't. And I suspect there's still a lot of variability in the market that is just unaccounted for. That's just like pure weird sentiment. Someone did something that echoed out, and you just don't know. So there isn't like a precise like a optimal win as there would be for like chess or for Go. Like the domain space for coverage is pretty wide. So I think they're going to run into that era or yeah, error. But yeah, I don't know. There are undoubtedly people already doing GAN models and AI models for the market. But we haven't heard of them for either they're doing very well, and that's why we haven't heard of them, or they're not doing well at all, and that's why we've not heard of them. I just don't see anyone wanting to talk about it because it opens them up to a lot of competitive pressure. Which like why share? I mean, do you think that Goldman or JP Morgan does not have a team sort of working on this? They've got the capital to spare.
Oh, I've got some funny stories about that, but a lot to respond to. I'll go in order before I get to the stories. The first
Okay.
thing I just want to mention is he mentioned overfitting, which,
Mhm.
just so people know, that's when, especially when you have like a deep learning model that's essentially trying to find connections and build connections in data. It could basically build an equation that scores very high, but the overfit part is that it is building an equation that is just really fitting well to the data it's seen, and then breaks very quickly on data that it hasn't seen. Because you could look at it like a massive guess and check system, like a neural net, and it's just like guessing and checking until it finds something that works. Is that a bad way? I saw you made a little face.
Yeah,
Yeah.
no, no, no. I mean, imagine you've got trading data from like 2001 to like just at like December 2001 to 2008, and like you missed the 9/11 crash and the 2008 market crash, and it's like, oh yeah, but I've got that. It's like, oh man, I've got this really awesome model which predicts everything always goes up, and that's your training set. And then magically it doesn't work because you've got black swan events. So I mean, there are uh, yeah, it's if your data isn't broad enough and it doesn't have enough coverage, and to do that well at this point, you need data going back to the 70s. You need to account for huge global economic. We've had like three at this point, which is not n of three is actually not a lot to train on. So you're trying to get ahead and manage against or hedge against the risk of like a big black swan event. You've only got three to look at roughly in sort of the modern data time frame. So overfitting is probably a really big problem.
Well, I think that's what's very interesting about it, which is just that um, I've actually obviously done a lot of different stock models. And when you widen, the most accurate ones are actually shorter term. I found like the optimal is about 6 months of training, because the further you go back, you might actually get a wider space. Um, but you basically are learning on irrelevant information. Like the market
Mm,
changes and evolves in systems. Like even if you just look at like algorithmic trading and when that entered and how different the trading patterns are based on
yeah,
that. Like the
yeah,
older data before that, it's like a whole different market. So it actually on wider scales, and this is something where you really dig into the models, on wider scales, you'll actually train and test better, but they actually perform worse because you're basically the
yeah,
equations that you've built like aren't really relevant anymore.
right.
And like even an LSTM model, which is for those that don't know, it's long-term short-term memory, and the idea is that a lot of models like can kind of weigh time equally, and LSTMs were built to account for time and also like weigh recency a little more. um but the very interesting part about it is that one of the things we do to account for what you said is we'll actually train with closer to 50-50 up down
Mm,
scenarios, because the
yeah,
market
which is smart.
generally goes up. So your models are going to just predict up if you take like, especially if you're like talking about a 6 month time horizon.
Right.
um we are, if that's the case, a lot of the times a market could just be up for 6 months, and then surprise, surprise, you're going to build models that like all they know is most of the stocks going up. So there's actually like a big
Right.
problem in some of these, larger models, where if you just train on like generally a bull market, you'll just have models that are pretty accurate, but when you dig in, you'll actually see that they're just always predicting that the stock will go up.
Yeah.
um
Now, see, so that's interesting. Where sort of like where you talk about sort of like picking the training data more selectively, because if you cast like a wide net, like, hey, I'm gonna let the universe speak for my training data. That is making an assumption about like the future will look like the past, which isn't like I think every hedge fund or every market investment that says like past performance does not indicate future success. Um, so picking your training data to make your model more robust is like a really smart strategy, and like that is where I think the GAN you sort of hit on is like the GAN model, where you have sort of like one AI model trying to design market historical data that is ugly and hard to predict, and then another model saying, "Hey, I want to trade in that environment and still win." Like those two competing against each other is really interesting, because you could have a model that's like, "Hey, like I'm allowed to give like a black swan event, or it's like a random drop that is like unexpected." like way beyond, like the implied volatility that would be normal. And it's like drop them in if the whole market crashes or one sector crashes, and like designing that, and then trying to like build a model that can sort of deal with that risk and hedge against it is really interesting. But then you still have to run in the issue of like, well, the advantage is not necessarily just surviving it. The advantage is being able to predict those big events. And that's where like getting a GAN that can sort of fake data is hard, because to fake the data, you have to understand what the data is. And now you're back to the original problem. Like, okay, can I read in enough Twitter data? Can I read enough news data? Can I read enough emails, illegally or not, to predict, to see a big event, to see a big swing that otherwise wouldn't be just in the market numbers. I mean, I know like the high frequency. A friend used to do high frequency algorithmic trading, and they were just on the data side. They're like, we don't do the trading, we just sell the data. And they got, I mean, this is early days. They got dinged because they were in, I think, one of the jobs reports days. They were in the room with a BlackBerry, like holding it up, recording it, and then they like ran out the room as soon as like the first 2 minutes were done. Ran out and like let it, like held the BlackBerry up in the sky so it could transmit the audio file, which then got processed because it was faster than them typing. Processed and then released, like trading tips within like seconds. And seconds to get up there, and then like they were working on like millisecond to issue guidance. I mean, like that sort of stuff that was 10 years ago. I can't imagine the craziness of like algorithmic trading and data, data vacuums today. So I think that is where the fun part of AI in the market is just getting through all the non-financial data to figure out what is actually predicting financial outcomes.
Yeah, and I mean, I think that you mentioned something that I was going to actually tap on next, which is
Yeah.
black swan events. And the biggest thing that I've learned from, I mean, I've been doing AI in finance for 12 years, but equity models about 8. And the biggest thing that I learned about trying to predict the future with market data is that like that essentially is a fool's errand. Like, yes, and a lot of how the signals are designed are to help grasp at this pretty much impossible problem and help people
Yeah.
grasp at that, instead of being like what I think too many things doing, saying like, oh, I've solved the problem. It's like, no, you didn't. Like, especially if you're talking about data for like retail investors that help them help them experience things, or trade against the best hedge funds.
Yeah.
And which is why we focus more on like visualizing institutional bets versus betting, like trying to beat them, which is like anyone that claims that is probably either inexperienced and doesn't know, or like intentionally selling snake oil. But what is really important, and like why we have like net option sentiment that refreshes every 3 minutes, is like ultimately like accuracy became less and less important to me, and flexibility and speed became
Mm.
more and more important. Where it's just like
Yep.
the example we're talking about with Google. Some of the things that I like is like black swan events are only problems for people that move slowly, right? To the point about like recording it on like, let's use September 11th. Like, let's say there was Google then. It happened like now. Everybody on their phones and searching whatever, who's going to know first? Google. Like, people are going to be Googling it, people on the ground, like maybe they're even listening, anyone that has access to that data set is going to be able to, if you have the right compute, you have the right brain, you have the speed, that's really how you tackle black swans. Because everybody talks about like, you're talking about like, oh, you only have 3. Black swans are like inherently unpredictable. And actually, I think the more time and compute, and any resources you use to try and like predict black swans, like that's actually taking away for ultimately like the resources that you can use to like react to
So,
anything that happens.
yeah. So what I would say is like the time thing is interesting. So where I think it's been most interesting sort of watch is there's the speed with which the market reacts, and you got sort of like retail and then sort of like institutional investors operating at different speeds. But then there's the speed with which the government reacts to large market events, and they are never going to be the same. The government will never respond as quickly. So I think there's a fair amount of play to be made about sort of like just the sort of the call it the arbitrage ish between sort of like where the market you where you think the market's going to react and when it does versus when you think the government's going to react and what it will do. There is that space in between, which is for a savvy investor. It's like, hey, I know it's gonna I know this is gonna crash. Look at the sort of like the Silicon Valley banks. It's like, okay, I know, like I can see this happening, or it has happened. I'm gonna act fast. Now the real play is trying to figure out, okay, well, how long will it take the government to actually do something? And trying to guess that. Will it be on a Thursday or a Friday? Will it be on a Sunday because Congress doesn't want to, they want to sort of be hidden behind the news of the weekend, or they're going to dump it on a Friday trash. Like, oh, we're secretly going to do this. So there's like very predictable political patterns, probably more predictable than the market. And I think understanding those is probably a good first step to being prepared for the black market, because like, great, it happened, the thing happened, trade, get your, manage your risk immediately. And then then you can go back and look at history for like, okay, well, what did other White House administrations do in this moment? How long did it take them to actually respond? Because like, how many times we gotten to like on the current government shutdown, how many times we got into brinksmanship here? How long does that last? I mean, to say that the shutdown is not going to impact the market would be insane, but you can make a reasonable guess, like, okay, we probably will shut down, and if that happens, it'll last X many years. Just guessing off of like what has happened before, and make smart bets about that. So
Yeah, no, I think some of those things are repeatable patterns, and you do like it makes sense to have models or models that encompass those things well. But yeah, I think that the big thing is having a reactive system, and one of the things that like data sets that I look at is our own models predicted accuracy. So
yeah,
I can basically look at the volatility in the models. And if they're normally predicting at certain rates and all of a sudden they're essentially less confident, that tells me either I need to start looking at things differently. And like, that's the nice thing. You drill down, you look at the features, you basically look at the features that the models are using that look at it differently. And like, you can kind of play data detective a little bit there. But I think that's the fun thing. And to your point, there's all of these different data sets that get into the market. And one of the like interesting things about Silicon Valley Bank was that the market just obviously like reacted terribly to it. But if it reacts terribly enough, all of a sudden Jerome Powell comes up and says
right,
like, we're going to help. Like, and then actually that was the start of the biggest bull run of the year. Like that actually ultimately like took us out of the bear market that day when Powell was just basically like, enough is enough. And had that crash not happened, we might have seen more of a slow burn down. But we got like, basically we hit the circuit breaker enough that he was just like, I got to stop this. So your point is a good one there, where it's just like, even if you have a good feel on like the market direction, you have kind
right,
of all of these data sets that can interact. Like another really
yeah,
good one, and that I always talk about in terms of like, if I'm bullish, the one thing that I always like to remind people is just like, hey, but if China attacks Taiwan, like you gotta like get the hell out of here, because like no
yeah,
matter how bullish I am, I'm going to use that caveat, because I mean obviously any potential risk with China, the market is very very worried about. Like I mean even Russia attacking Ukraine, people were worried
yeah,
about, and that didn't really like involve us. We weren't really doing as much posturing, and we were a little with Ukraine, but even so, like for those that don't know, Taiwan Semiconductor supplies a lot. Like they supply Nvidia, for example. Nvidia just designs chips, they don't make chips, or they've started to like make some, but the majority are coming from Taiwan Semi. So all of a sudden you have like a macro risk, and like our lifeblood of AI, of tech, like could be cut off or changed. I think that's a big reason why we passed the chips bill, to combat that risk a little.
yes,
But that's going to take time, and that's always the caveat that I make on that. But that's why that's why I think there's some retail traders, and I always caution them, that get really excited that they feel like they're on top of things, and it's just like, well, yeah, some of that is just like you're doing the easy part. Like the hard part is when something happens that people aren't expecting. Or like I saw like towards the end of this bull run, I saw a lot of like way too confident retail investors that really had their lunch handed to them in the bear market, where it's just like, yeah, everything looks easy. And the mistake that a lot of people make is they'll pick high volatility stocks and thinks that and they think that means, or like small cap, high volatility, maybe both.
Yeah.
And when those go up, everybody thinks that means they're smart at picking those stocks. And if they have social sentiment, even better. But the problem is in bull markets, those go up big because a lot of people want to take chances on those like big growth small cap companies and they can get momentum. But it's pretty much the complete opposite. Those are like the first companies that people unload and the ones that get the most momentum downward in the bear market. And the important question then becomes, when are we in a bull market and when are we in a bear market?
Right.
And that's what people really get paid the big bucks to do.
Yeah.
Not, picking high volatility stocks in a market where everything's going up.
Right. Everyone's a genius in a bull market. But it's funny you sort of brought up the CHIPS Act. So one of the things I do sort of long-term product strategy, and when you're working for NASA, the field of strategy that you're thinking about is sort of like 30 to 50 years out. So it's a very different sort of like game to play. But it's sort of interesting if you are looking at the CHIPS Act and you're looking at NVIDIA and AI, and you're trying to see this sort of emerging trend around sort of like, oh, well, AI is going to need more compute. We start looking at like, what kind of compute is that going to be? Is that going to be on-device compute? Do I need smaller chips? Do I need more performant chips? Do I need chips that are not going to go in a rack, but are going to go on my phone that run or tune for AI? Like that's the sort of stuff where like I would be paying attention if I want to understand that space. But the CHIPS Act and sort of like, hey, we're going to start building and doing more semiconductor stuff in the U.S. Well, what that does is actually sort of reduces the U.S.'s need to sort of defend Taiwan, right? Like right now, it's like, oh, it's the heart of our AI, our whole AI infrastructure is sort of built in Taiwan. Well, if we start doing it domestically, and then China what is China? Their response to people, maybe they start putting more pressure on Taiwan, and we're like, well, we can let them get away with more. We're not going to be as responsive because it's not as much of a risk. So now you start seeing like, well, what is NVIDIA's response to China's potential increase in sort of aggression towards Taiwan? I mean, it's does NVIDIA start like, oh, we're going to start trying to buy and source chips and build chips elsewhere, not be as so dependent on Taiwan? It's sort of interesting, sort of like these are the political machinations where you have sort of like they are predictable. You can see these things happen 5-6 years out. But if you're not paying attention, these are the things that will actually drive the sort of like larger swings in the market. Because one day Russia will invade Ukraine, and if you were surprised by that, you weren't paying attention for the last 5 years. And the smart people are like, oh yeah, like I can see aggression, I can see these things happening. I'm going to buy commodities around grain and oil here. I mean, so there are definitely people who were not surprised by it and made a lot of money. So I mean, there is data and information to be had there if you're looking for it. So.
Yeah, and I think that's like a problem that we obviously keep touching on. There's understanding kind of the linear relationships between these things. Like Taiwan taking Taiwan, bad for market. Like Russia attacking Ukraine, bad for market, good for grain. Like those are linear relationships that a lot of people can build. But again, the challenge is mostly building these like non-linear equations that say like, what is this going to happen, or what is the probability that this happens, and like planning around that, building basically like expected value equations that make you money out of the probabilities of that. And for those that like don't know the relationship between like probabilities and expected value, it's basically like, let's say you have a 50-50 outcome of something and you bet $1 on each, right? You're going to make guaranteed, like you're expecting to make that, back essentially, but you're not really expecting to make money either. It's just like, and that's like the easiest one to understand. And then obviously there's like what funds are doing, and a lot of them use probabilistic systems. And actually that was going to be the next segue, because I'll have you comment on some of the structures that I know that funds use. But they're basically like looking at the probabilities of all these events and always hedging. And this is why I always tell people to hedge, where just like funds don't really, they'll still sell options, but they don't really buy naked options. And what I mean by naked options is like, things that I'll suggest all the time, where like if I'll buy, like for a while this year, I had Meta and Tesla long-term options. And then I also owned SQQQ call options, which is basically like that's betting like as SQQQ goes up, it means the QQQ is going down. And so that's also like double leverage too, because SQQQ is 3x leverage and an option is like further leverage. So basically, I was just balancing that out. And that's what most funds will do. And basically, what I'm betting on there specifically is just that Meta and Tesla will do better than the rest of tech. Because as long as that happens, even if the market is down, I will have made money on that trade as long as those stocks outperform the QQQ. So that was my bet. It wasn't that those companies would go up, which is a different bet than I'm just basically saying, like, I think if any companies do well in this market, it will be these two. And that's how hedge funds think, but that's a smaller slice. The two most popular strategies that I know hedge funds use from a high level is essentially like these large models, same kind of things that run, ChatGPT or whatever. You're basically getting like a lot of computing power, a massive data set, and you're just basically asking it to solve a massive nonlinear equation of mostly resource allocation. Like we're talking about like where to put those trades, how to balance these scenarios, and you have basically like a big brain doing that. But there's also like the opposite, and these systems are kind of older. The larger models have become more in vogue, but there's still some of these smaller models that can compete or win, and that's like multi-agent systems. And those are, for those that don't know, basically smaller. You might think of them as organisms. So you might think of it, the easiest way to think about it is you might say like, okay, I'm going to give one computer to this organism or one core of a computer, and I'm going to ask it to just trade. And basically, like these things can live or die based on how well they do that, but you can specialize them in different ways. You can say, like, your job is to just trade Apple, learn all about Apple, read the news about Apple, trade Apple. Like up, down, swing trade. You could ask it to just like only enter it in certain scenarios. And basically, like these systems, then you actually have like a brain on top of those organisms that basically decides how those get resources allocated to them. Any other ideas? Are those two of the best approaches that you think you would use?
Me? I mean, I think I definitely think the multi-agent solution of like is the right way. Even in sort of like the large language chat GPT research right now, they're like, oh, no surprise, yet again, a multi-agent version of this is better than the sort of sole version. And they're doing that right now. They're like, yeah, we're actually going to ask, three different versions of this with three different slightly different instructions to go and solve the same problem. And then they're going to collaborate at the end and sort of like, hey, which of you think, like judge the other two? What do you select? And like, or some sort of round robin, but like they're getting really smart about this sort of multi-agent solution. Because I think the idea is that if you have one model, models can get sort of stuck in a rut, right? You can have like, they can have like upstream make one bad decision. And it's sort of like they're sort of optimizing local optima. They're solving for that like one little dip in the road, not for the massive dip that's later on. So by having multiple agents, right, you can sort of like have them challenge each other without getting sort of stuck in the computational rut. And that's, it just yields better results. It's diversification. It's, it's like, why buy one stock heavily when you can buy a whole bunch and diversify your risk? Same sort of idea in AI. But yeah, it's happening right now. So multi-agent models are definitely should be coming back. I didn't know they were out. I guess they're now more in vogue. But yeah, I am interested to see this, the unification of sort of like the old school models with sort of the new compute built around the large language models, because it's different. They're solving different types of math, and I'm interested to see sort of like how these things start working. You can already see people using like ChatGPT is like, well, what do you think Apple's going to do? And it's not going to give you a great answer. But if you were able to give it better data, and like more broad swath data, it might come with a more nuanced approach that you can then again validate against your old school just numbers, just stock data input. But yeah, that's gonna happen. I mean, there are companies doing that, today, and I'm sure they'll be, running the game tomorrow. So
Yeah, that's a good point. I was kind of thinking of it as an either or, where you have like a massive amount of smaller organisms, or you have kind
mm,
of like this large computing organism. But that's a good point. You can still have multi agent and kind of, weighting of opinions with like, the bigger brains as you can with the
yep,
smaller ones. But I think what works about the smaller ones specifically is that there's just millions and millions, and they just basically they tackle
yes,
the problem that we were talking about of, you know the biggest thing is like, you can we I don't know, I built millions of models myself. At one point we had like a science machine that built like 100,000 models in a day. Um, and the thing about it was that you could, like, they all performed well in different scenarios. Especially some perform better in bull, some perform better in bear, and some, more neutral markets. And it just was a question of like what it was. Some of the problems that we were talking about earlier. But um, the hard problem was like, what kind of market is this going to be? Like,
yeah,
and the successful multi-agent frameworks solve that problem by not solving it by just kind of using, you might say, a who's right kind of system.
yeah,
Like, whoever is like predicting well that day, or as the markets are
yeah,
changing, um, they um, they basically get uh, they basically get to, um, get more resources. And they basically,
yeah,
like, they'll there's a conditional weighting of resources where, like, okay, these models start to perform well, more models like them
yeah,
get, votes or weights or resources to like build more, make more predictions. And
yeah,
like, that was the best way to solve that problem before some of these larger models got better. Because it really, like, like we've talked about, that problem is pretty much the toughest
yeah,
problem. And just like avoiding, like, kind of punting on trying to like create rules around it, and just basically saying, like, putting it to the computer to figure out is kind of the only way anyone's even been remotely successful at solving it.
yeah. So you hit on something, and I do want to make sure, sort of like common misconception around AI, that I think would be useful is that, these models that are being trained right now, they are massive and they are very expensive to update. And so the analogy I use with my teams, and colleagues is that it's sort of like a jawbreaker, right? So like when you make a jawbreaker, you can't like crack it open and like pull out a layer and say, I'm going to tweak this and put it back together. Like that's not how jawbreakers work. The candy, it's like it is a lots of tiny layers. Like once it's baked, once it's hardened, it is what it is. You can add stuff on top, right? You can sort of fine tune, as they say, sort of like, oh, I can add another candy coating of red and strawberry, whatever it is. But they're sort of locked in. And where I think this sort of goes back to some of the stuff we were talking about sort of earlier on sort of Palm 2 and the Google's models. But a lot of the stuff you're sort of seeing right now, sort of the fancy AI predictions and everything out there, don't be fooled by it, because behind the scenes they are running basically a Google search, reading in all the data, and then throwing that into an AI and say, now make it sound convincing. So all the AI is doing is convincing you that it's really thoughtful, as opposed to here's a list of 10 results, you read it. It's just doing the reading for you and summarizing it, and that can be helpful, but it's not. It doesn't have this grand information. In fact, the information it was trained on is probably 2 to 3 years old. So it's only pulling in this most recent, like again, Google search. So the models themselves, the ones that are going to get really interesting, at least around sort of financial markets, like if you see something, oh, we're doing this model every day, the reality is it's a Google search and they're making it sound fancy for you. It is not the advanced stuff that George is talking about, sort of like multi-agent models. Like that requires that you be training your own model, that you host your own model. And this is where I think sort of Google's focus on making their models not better or more sort of performant from a large language. Oh, look, we can write something closer to Shakespeare. I don't think they care about that. They're like, hey, we have something that's good enough, right? It's Hemingway. It's not Shakespeare. It's Hemingway. It's a short, easy sentences. I can understand it. It was raining. I was sad. Cool. Um, they're making them smaller, right? So they're it's cheaper and cheaper and cheaper to run. So they hit that like 98% mark of like quality, and they're like, yeah, now we're just gonna make that 98% 50% cheaper. And now you can start to see sort of like George, what you were talking about, sort of the, oh, I can run 10 of those for the cost of running one big one. What does running 10 do for my diversification, for my strategy, for my ability to sort of like interpret lots more data, to update that model and train it? Because like, hey, it is smaller. I can train it. Or GANs, I can have them train each other competitively to sort of keep themselves up to date. So if you see, I would say like, to me, is it keeping an eye out for bringing the companies bringing down the cost of the models right now. Those are the ones that I think are going to be again not tied up in like having to buy the most expensive chips. They're not going to be sort of focused on that. They're going to be, it's going to be the first movers in the sort of the commodification and sort of scale space. Those are the ones that I think are going to have a real advantage in trading and all other forms. So
I want to get to I want to hear your thoughts on a few of the stories I was going to tell you about.
yeah.
You mentioned Goldman, and then we have to do our little fun activity before we end. If anyone has any questions, we are ending. I know we normally wait a little longer. We're ending right at noon because I have or noon Eastern, because I have another meeting. I'm actually late for an investor conversation to like they asked it, and I honored this. I was so excited about this AI talk, but. No, there's other people starting the meeting without me. But so my favorite AI stories, like the first one is at JP Morgan, and basically they actually built a big problem with trading. I mean, you're probably familiar with the term tilt in poker. Like a
Hmm.
big problem with trading is actually people just basically like losing it and gambling a bunch of money, or losing money and deciding that they're like going to get fired, and their only way out is to like make these crazy bets to try to get out of it because they're going to
Yeah.
get fired anyway and it's not their money, you know? And they're just
Yes.
like, hey,
Yes.
I'm going to take risk. I better make it back because I'm going to get fired regardless. So JP Morgan actually like built an AI that would like analyze people's behavior, like what time they
Hmm.
came in, like things like that, to basically like analyze that risk of someone just like mentally breaking. Um, and
Yeah.
what they got was like the person who basically oversaw that program basically had such an insight into like people's lives at JP Morgan that he ended up blackmailing people. Like it was like the head of security or whatever, and he had just like very valuable information. And there's like an article, I forget what it was, but it was like there was an article that broke about this. Like it's the reason that I know it all. This is not inside information. This is public
Yeah.
information. But it's so interesting because like basically it kind of ended like, yeah, we think they shut that project down. Who knows if they shut it down or they just like put certain training wheels on it or whatever. But that's always like, that's the funny thing about the power of these programs, where it's just like there was a head of security before. I'm sure he could have read all the emails that he wanted, but it was like an intractable problem for him to like find dirt on people, until this AI basically was like signaling all of the unstable people for him. And then like the dirt was plentiful.
Yeah. I mean, you don't even do that. I mean, imagine how powerful just having like the registry list for like who's playing the back nine. Like, what CEOs of Fortune 500 were playing the back nine more this quarter? As like, is that? Do you think that would be indicative of performance? Yeah, probably. I bet you there's some economists out there who would love that data. But I mean,
Wait,
the like,
are you saying worse or better performance? I would guess better, actually. It sounds like you're applying worse.
oh, I would say worse. And I bet you I could dig up a paper that says CEOs spending more time out of the office is an indication of confidence, but probably predicts longer term poor performance.
False
I'm
confidence.
I,
Interesting.
I'm
Yeah.
yeah, I'll make that bet. Uh, yeah.
I would say I would definitely say the opposite. That's so interesting. I would say that like, normally like the job of a public company CEO is like so demanding and like high profile, and everything is like, I would say it's like, I would say it's too big of a risk to play golf if you're not um sorry, if you're not um basically, performing well, but who knows?
Yeah.
The other one, I'll do this a little quicker because I want to get to our last little fun activity, is that Goldman basically, for the longest time they had, and I actually met the guy who was the primary author of this. I don't know if it was built by Palantir. No, I think it was internal. Like, financial institutions do not let people touch their data. Like, I could say confidently, like any other business, I was like, yeah, maybe Palantir, even the government. Palantir's like could touch. Finance institutions are even more particular than the government about who touches their data. But so
Yes.
basically, Goldman, for a long time, like always the expression with Goldman was, don't do business with Goldman. They're going to get the better of you. Like, even like the savviest finance people. And
Silicon Valley Bank, anyone?
yeah, exactly. And I recently, like I in the last 6 months or so met basically the primary author of like Goldman's SecDB, which was a universal securities database that they've had for a long time. And the funny part is that was essentially what was doing. You could be trading this like exotic fixed income instrument, and Goldman comes to you with a price, and you're just like guessing at that price. But they basically have like a all-encompassing securities model, pricing that, forecasting the performance, and it was just up against people for all these years. So that's like a funny AI story about like, oh yeah, I'm sure they have something going on. Like, most people, even as they became aware of SecDB, didn't even understand tech well enough to know exactly what they were up against. And like more people have become, I think, especially with AI, tech savvy now, we're just like, oh yeah, that thing can probably beat me. But most people, like even knowing that existed, thought they were better than computers for so long. And even at Goldman, there was a big thing. This is what I always say, like, there's some conversations I have about football where they're basically like, oh, like a model could never predict the game of football. And I was like, that's literally what all of the Goldman, like the people at Goldman said before, like now, like that's the engine that runs it. And they like don't have traders always thought they were smarter, but now like most of their best traders are called straders and they code too. And like they have a whole special floor for them and everything, but it's just like that's the classic. I'm sure you've seen it a number of times where it's just like, oh, like people are much better at solving this problem than computers. And it's just like,
Yeah,
no, like not
I'm
now.
not a I'm not a huge football fan. I grew up in New Orleans. Like the Saints weren't particularly good for most of my life. But I love fantasy football because if people want to bet that their skill as a human is better than my algorithm and data crawling, sure, great, give me your money. It's a real fun journey to experiment. I got like 3 or 4 leagues, different models running on each. It's IDP is hard. IDP, the variance on IDP is hard. But yeah, no, please give me your money. Make that bet.
Yeah. All right. We're gonna do one more, and like we're gonna do this fun activity. Sorry, I'm talking. I'm trying to multitask here, but we'll just do one each. It's a fun game I like to play with people that know AI. James is gonna throw a business at me, and I am going to say how it's improved by AI, and then I'll throw one at him. And we probably only have 2 minutes for
Mm.
each, so let me have it. What business?
Ooh, wow. JC Penney.
All right, JC Penney. The first thing that they need to start
Mid-market
doing,
mid-market fashion with lots of physical infrastructure.
they need to start using all of that camera data to figure
Mm.
out what inventory to carry, figure out how to staff salespeople, how many salespeople they need. Maybe they try and experiment, A/B test some kiosks in their stores where people can maybe just like request things and be directed to where they are, order things like that. They need to look at supplier relationships, the types of fabrics, relative costs of fabrics, create basically net present value equations of what is going to sell all the way up to how those are built, the cost of those, and basically like optimize that whole process. I think they
Hmm.
need to review their marketing strategies and commercials a little more intelligently. Most companies are really bad with marketing dollars and they're just really guessing. And basically being able to analyze, okay, I have this marketing spend, where is it actually
Hmm.
going? And are things like, do you like, I've always thought of things like, okay, do we just like cut marketing and instead lower our prices. There's tons of like optimizations that I think especially retail based businesses could do. But now you see how it works. I'm gonna throw it back at you and say the Bronx Zoo or any zoo.
Okay.
Tell me how you would
Okay.
AI a zoo.
Oh man. Well, I think back to the cameras part. I bet you there's a fair amount of data that they could sell on cameras on sort of like animal habitats and sell that live data research or aggregation or models around some tracking where the animals are and what they're doing. Tons of researchers would love to have live stream data of animals. Obviously, it's in a zoo and not out in the wilderness. But I mean, a zoologist trying to study that stuff is like, hey, look, we'll give you a live camera feed and work with you to build an AI to track. Yes, this is how many fleas they picked out of their partner, and like, oh, it's gone up because of stress levels, whatever it is. Like, there's tons of zoological research that they could probably monetize to then fund getting more animals, lowering prices, getting more stuff out there. I think that's possible. But on sort of the retail side, it's like all the stuff you said around sort of like, hey, getting more people in. I bet you there's a fair amount of optimization to be had around like temporary animals. So like, hey, we're going to transfer this animal from this zoo. We don't have it normally, and like, how do you optimize sort of transportation, logistics, safety, weather, security, what time of year you move them? So moving these animals around between zoos can be disruptive, but you could also like, if every zoo gets an exotic animal that they don't normally have, they can make a big marketing event around it. But you're trying to basically optimize animal swaps across a whole network of zoos. Right now, they do it. I think like a few years ago, it was like a spreadsheet. They're like, we've got these elephants we need to get rid of because we can't afford them anymore. And there's some like sort of cloud spreadsheet, Google spreadsheet, where they were like handling all this stuff. That was the tech level that they were operating at. I think you could improve it a fair amount, and then obviously sort of like a win-win on animal show optimization, while respecting sort of the needs of the animal. Like, hey, yeah, don't send a Sahara era, like a equatorial animal to New York in the winter. Fair, fine. But you got to account for all that stuff.
All right. Well, James, thanks very much for joining. I have to
Yeah,
hop
it's
to my
pleasure.
other call. Thanks to all of our watchers, and have a great rest of your day, everyone.
Have a good one. Thanks, George.
Bye.